Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. So now we are in chapter 5, if according to Stalling Books, and we are in lecture 4. Okay, the title for this week is Concurrency, Mutual Exclusion and Synchronization. So the learning outcome for this topic are, we are able to, by the end of this topic learning session, you are able to discuss the basic concept related to concurrency, such as race condition or as concerns and mutual exclusion requirements. The second learning outcome is identify the different approaches to achieve mutual exclusion. And the third one is to explain the operating system approaches for supporting mutual exclusion, namely semaphore, monitor, and message passing. Let's look at this mind map. So these are the topics, the subtopics that we will cover in this topic. Okay, we are going to see what are the key terms in this concurrency topic, and then what are the OS concerns and the issues of concurrency. Then we will look into the requirements for mutual exclusion and what are the process interaction that involve, which requires a mutual exclusion, and then also involve in deadlock and starvation problems. Okay, and then we look at how the computer system able to enforce or to implement the mutual exclusion, since it's very important to meet concurrency and synchronization. So we have three methods that are hardware, software, and also operating system. So in this particular topic, we are going to more concentrate on the operating system approach. Okay, so in order to go more further, ensure that you have the idea what is concurrency. So concurrency is the execution of several instruction sequences at the same time. Okay, so we are going to see the details of the concurrency in the next slide. So the concurrency involved in where we have multiple processes. Okay, so we have the multi-programming, multi-processing, and also distributed processing. So in multi-programming, we have multiple processes that execute within a uniprocessor system, so that the processor need to interleave the process so that to allow multiple process to be executed, okay, based on their turn. Okay, multiprocessing on the other hand, multiple processes but within a multiple processor, so we have that overlapping of processing because we have more than one processor. So at least two processors, if we have two multiprocessors, so at least two process will be executed at the same time, right? Next is distributed processing, which multiple processes executing on multiple or distributed computer system. Okay, so we have more extent size of processor. Okay, so the example of this type of processing is the clusters based processor. Right, we go next. So what the context of concurrency that might happen? Okay, So we have three contexts. Okay, so there are multiple applications. The design of multiple application which allow processing time to be shared among active applications. So nowadays we have computer that able to pick up with multiple applications that execute at the same time. So we able to open up our PowerPoint, we open up our email, Microsoft Word, and then we keep interchange between these, right? So so this is example of multiple application, right? And then what's more, it's about structured application. So in the application itself, we have the modular design and also structured programming, which allow multiple process within application. So that's why we need, maybe like they have the sharing of a variable, okay, in the particular application. So these two are related to application. And actually the operating system itself also requires concurrency, okay, which the OS themselves implemented as a set of processes or threads. So basically they are also requires processor time, right? Okay, so these are some of the key terms related to concurrency. So we have atomic operation. So what is atomic operation? Okay, in short, it's an operation that always run to completion or not at all. So like for example, we in our daily life, we want to use the toilet. Okay, so for sure, if you go into the toilet, you must finish all the business before you go out. Okay, no one can interrupt you. So this is atomic operation where we requires the operation must be complete or do not start at all. So that's atomic operation. The second one is critical section. So critical section is related to the critical resource. So we are sharing those resource and also the source code. Okay, so if we refer to this table, showing that critical section is a section of code within a process that requires access to shared resources. So it might be your memory, it might be the your hard disk, so it is shared resources. Might be your printer, okay, I/O channel, right? So it's something like related to sharing. So we are not allowed basically more than one process to execute in the critical section. Okay, so we need to understand first the term or the definition of the critical section is the section of code within a process that requires access to a shared resources. Okay, deadlock. Deadlock is a situation two or more processes that unable to proceed because you are waiting each other to do something. For example, you are in a junction, okay, so all the cars need to move forward, but you are waiting for the other car to give away for you. But if the car did not move, so you are stuck together. You cannot move in both ways. So in computer system, if there is no control, so the process will stuck waiting for resources. Okay, next is live lock. Life log is where you can basically the process able to change their state, but you are not doing the useful work. For example, um, I relate to the toilet again. So for example, in a toilet situation, you are assuming there is someone in the toilet. Okay, and another person might be, we have two doors of toilet, the other direction. He also, the other person also expecting someone in the toilet. So you are keep on waiting for toilet. There's actually no one in there. So you keep telling, I want to go in, but then, okay, I'm waiting for you to come out. And the other person will say the same thing. I want to go in. Okay, you are changing your status, but since no one respond, and then you say, okay, I'll wait for you to come out. So this is life log. No one is using resources. Okay. So this is the important. Okay, so this is important critical section, and now deadlock, and also now is mutual exclusion. So most mutual exclusion is related to the critical section. So it requires, okay, that only one in the critical section to access at one time. Okay, so meaning if you are in a toilet, no one can come and interrupt you to from doing your business in the toilet. Okay, and only when you finish, then you go out, and then the other user can use. So this is a requirement. You must follow this requirement so that it won't interrupt any process that currently processing its data, for example. Okay, next. Okay, so we have go through the atomic operation, critical section, deadlock, life log, mutual exclusion. So for rest condition, we will discuss on the next slide together with the starvation.